Today we're going to be doing a grasshopper dissection. And a grasshopper is an arthropod, and as such it has jointed appendages. If we take a look at this grasshopper, we notice the joint here and here. And let's go ahead and name some of these structures. This is obviously the large jumping legs that allows the grasshopper to jump great distances. And on this structure right here called the tibia, and we also have a tibia, are spines or hooks. And these spines or hooks are designed to grab onto vegetation. So as the grasshopper jumps, these spines or hooks grab onto vegetation so that the grasshopper does not go all the way back to the ground. So it's going to be a more efficient means of traveling for the grasshopper. This also keeps the grasshopper on top of the vegetation where it can be more aware of its surroundings. Now, the next thing I want to take a look at is the different body regions of the grasshopper. As an insect, it's got three body regions. It's going to have a head, which I'm flexing, a thorax, and an abdomen. And we can see those three body sections right here. Now, how do we tell the difference in sex between male and female grasshoppers? Well, in my hand I have a female grasshopper, and if we take a look we can see this large structure right here. And I'm actually going to put the probe right inside here. This is called the ovipositor. Now let's see if we can get a close-up shot of the ovipositor. There you can see the ovipositor. And this large structure right here is going to be used to dig holes into the soil and lay eggs. Now with the male, we're not going to see that ovipositor. This is a male. If we look at the back end of the male, you do not see that large ovipositor. So that is one of the ways of telling the difference between males and females. Now the next thing we want to do in order to begin this dissection is to begin removing the legs. And when we remove the legs, we want to twist the leg off. We don't want to just pull it, but we want to twist the leg off so that we don't damage internal structures. So I'm going to remove one leg. I'm now going to twist and remove another leg. And you can see bits of skeletal muscle as I remove the legs. Now I'm going to do the same thing to the other side. I'm going to remove one leg by twisting, and then I'm going to remove the other leg by twisting. And again, you can see some skeletal muscle has been removed along with that leg. Now, let's take a look at the grasshopper's wings. You can see this large wing right here. This large flat wing is going to be a forewing. Fore because it's more anterior. This large wing is going to be used for two purposes. One, gliding, and two, protection. It's going to be used to protect a smaller wing that's underneath. So let's go ahead and take a look at this smaller wing underneath. I'm actually going to take this smaller wing and I'm going to fan it out. You can see that I'm fanning it out. It's very thin, very membranous. This is the wing that's actually going to be used to flap up and down and to make this grasshopper fly. This large wing would be too heavy for those purposes. Just like birds in the air, birds with very large wings often do not flap their wings too much energy. They use those wings for gliding. And the smaller wing here is very membranous, very thin, is going to be used for actually flapping and flying. But because it's so thin, it's very delicate and can be easily damaged. So we want to cover that wing up with a strong protective wing. So I'm going to go ahead and I'm going to remove both of those wings now, again by twisting the wing off and gently pulling, twisting the wing off and gently pulling. Now I'm going to do the same thing to the other side. Gently twist the wing off and pull. Twist the wing off and pull. This one's a little bit more difficult. Now, underneath the wings, we see a structure right here, and on the other side, the same structure. See if we can get a closer view of that. This structure is the tympanic membrane. And the tympanic membrane, or tympanum, is the grasshopper's eardrum. That actually vibrates in response to sound. That's how the grasshopper hears. The next thing I want to do is begin the internal dissection. So I'm going to get a pair of scissors, and I'm going to begin at the most posterior aspect of the grasshopper, and I am going to begin cutting up the exoskeleton all the way until I get to the head region. Now it's important to angle the blade parallel to the exoskeleton. You do not want to angle the blade down and cut into the organs. So I'm going to go ahead and begin to dissect this grasshopper by putting the blade into the posterior aspect, maybe making a small cut, little snips. And I'm going to gently work my way anterior. Again, I want the blade just underneath the exoskeleton and not gouging into the organs. I've made it to the thorax. I continue to cut through the thorax all the way until I get to the head region. Now once I'm there, I'm going to go ahead and I'm going to open up the exoskeleton. I'm going to do this very gently because there are going to be muscles attached to the inside of this exoskeleton. So I'm going to pull this exoskeleton open, and as I pull this exoskeleton open, I have to make one more small cut here. As I pull this exoskeleton open, look for small fibers that are going from the exoskeleton to the body of the grasshopper. And those fibers are going to be tracheal tubes. This is a system of tubes used for exchanging gases. So here we see all these yellow structures. They actually have some latex in them to give them a little bit of color. But if you do not have an injected grasshopper, you can still see these small fibers. And there they are. Each one of these small fibers is a tracheal tube going from the exoskeleton into the body of the grasshopper. And those tracheal tubes branch and branch and branch and deliver gases to all the cells in the grasshopper's body. There you can see some larger yellow ones near the head region. Take a good look at those tracheal tubes. Here you can see some more. Now I'm going to open this up and expose the anatomy here, the internal structures. And let's go through the naming of those structures. This large structure right here, sort of like a large balloon, it's very distensible, it can enlarge easily. This is the crop. This is where the insect stores its food temporarily before it goes into the next digestive structure called the stomach. In between the crop and the stomach are going to be digestive glands called gastric ceca. And let's go ahead and tease a few of them loose. They're like little flaps of skin. You can see them visualized right there. Gastric ceca. There's another one down there. And I'm just gently teasing these gastric ceca free. Let's see if we can get a closer shot of the gastric ceca. So there they are. There's the gastric ceca. Now the gastric ceca are going to be between the crop and the stomach. And where the stomach begins to narrow, we have other structures, small hair-like structures, difficult to see sometimes if they're not well preserved. But some of these small hair-like structures around here are going to be Malpighian tubules. These Malpighian tubules are just that. They're small tubules that are actually used to remove metabolic waste. So these are essentially primitive kidneys. These small tubules take metabolic waste. These are wastes due to chemical reactions, and they take those wastes and they put them into the stomach and the intestine. And then those wastes are removed with the digestive wastes. The smaller tube-like structure down here is going to be the intestine. Now, after we've finished that, let's go ahead and try to turn this over gently. And sometimes, if we're lucky, we can see a nerve underneath called a nerve cord. And I am not seeing the nerve cord. It needs to be a very well preserved specimen in order to see the nerve cord. Do not see one on this specimen. The last thing I want to do is to make a wet mount. So I'm going to go to the grasshopper's eye. And there's the eye. It's a large eye. It is referred to as a compound eye. It's compound because it has many lenses. By having many lenses, hundreds of lenses, this allows the grasshopper to see more of its surroundings, almost 360 degrees. And it can then look for predators in the area. So what I'm going to do is make a wet mount. I'm going to get a glass slide. I'm going to give it a cover slip. I'm going to get a dropper with some water. And I'm going to take a small shaving of this grasshopper's lens. Now I'm going to take a very sharp scalpel, and it's important that you always cut away from your fingers, never ever towards your fingers, and you want the smallest of shavings. So I'm going to get on that eye, and I'm going to cut just the very smallest of shavings. You can see that little tiny shaving right there, and then I'm going to get the forceps and gently remove it. I don't want to squeeze too hard because I'll crush it. And that little tiny shaving, I'm then going to take a glass slide and put that shaving on a glass slide. Now thin is better. I'm then going to take a drop of water, put one drop of water over top of this shaving. I'm then going to get a cover slip, and I'm going to put the cover slip on at 45 degrees, touch the water, and then let it fall. By doing this, it helps remove air bubbles. Now I'm going to take the back of my fingernail and gently touch it to the slide to make sure that it's in good contact. You don't want to use the front of your fingers because you can get oils from your skin on there, and you don't want to be looking at that. Now this is ready to look under the microscope. Start out with scan, go to low power and even high power, and you should see these wonderful hexagonal lenses, hundreds of them. And those allow the grasshopper to see almost entirely around itself. And that's going to be it for the grasshopper dissection.